Welcome you all. Today we are continuing our previous topic as a part 2, brief history of nanobiotechnology. In the last lecture, we had discussed many things about prehistorical era and the era in the 20th century. We will discuss few examples here and then the significance of nanobiotechnology and how it developed. We will discuss these things here. We begin with learning outcome, then the student specific learning outcome we will discuss. In this lecture, we will start with pre-modern examples of nanotechnology, then what we have developed in the last century, then in the present century. We will take some examples from Roman era, we will take some examples from Faraday, then in the recent time, then nanotechnology started with Richard Feynman in 1959. From there, we will take examples from development of many things like STM, AFM that leads to the rapid development of such field. And we will also discuss then how biology and biotechnology worked with nanotechnology to get various solutions to develop various technologies for human welfare. In this presentation, we are concentrating on initial stage of nano developments, then product developments, biotechnology as emerging area, which is a mix combination of nanotechnology and biotechnology, and we will also discuss future applications and potentials to develop many other devices and sense materials. As a specific learning outcome, such lectures will help you to develop your problem solving ability. You will learn how to use applications of theory and practical concepts. This will also help you to develop critical and innovative thinking skills and ability to collaborative work. Here you can see how Don Igler manipulated atoms and wrought IBM. It can only be seen through nano instruments like STM, because this is developed at nanoscale by manipulation of atoms. After the emergence in 1980 again, the field was growing, and in 2000 the field was subjected to growing public awareness and controversy in early 2000. The prominent debate about both its potential implication and feasibility of applications. Till today we have these controversy, whether it has some applications, yes or no. If it is there, what are the ethical issues involved? and how the application envisioned, how we will work with molecular nanotechnology, and how the government supports such type of great work. So many things have started in 2000. Soon after, many commercial applications were designed and developed. However, most of them were limited to bulk applications of nanotechnology rather than transformative applications. But it's a beginning, and we started work on this, we started thinking of things. As we have discussed yesterday also, the book by Eric Drexler, Engine of Creation, gave a lot of good feeling to the readers. As a technologist, it gave me a sense of calm. That is, nanotechnology showed us incredible path. If the nanotechnology was our future, then I didn't feel pressed to solve problem in the present. Would go to this book, this future, and I think we can enjoy life more better than this that we have if we use this book. If the vision of this book will fulfill soon. This is another book who created revolution in the field of nanotechnology, created by Drexler. This is a comprehensive easy to understand handbook that explains what is nanotechnology and how it will revolutionize life in the future. The world leading expert Drexler examined the spectacular accomplishment that might result from a breakthrough, elimination of disease and pollution. How can we create low power solar energy and many futuristic developments related with nanotechnology? So this is another thing from where we have created revolution through books. Actually, the revolution created in two types, as we have discussed: revolution through books, through study materials, and through experiments. So I'm talking about books and both experiments. Discovery of fullerene is an again a very important milestone for the nanotechnology. Harry Kroto won Nobel Prize of 1996 in chemistry along with Richard Smalley, and Robert Curl for their discovery of fullerenes. The fullerene were discovered with these people. These are carbon-rich grains. The result of collaboration was the discovery of 360 and the fluorine as the third allotropic form of carbon. The subsequent discoveries also included androidal fluorines and their large family of fluorines in the following years. Fluorines are the cage structures of carbon, and the size of the structures help a lot in development of many applications in nanotechnology. As we talk about what we have developed after the development of nanotechnology, yes, we have designed some initial commercial applications. And almost most applications are limited to bulk use of passive nanomaterials. For example, we have developed titanium dioxide, zinc oxide nanoparticles in sunscreen, cosmetics, food products. We are using silver nanoparticles in food packaging, clothing, disinfectants, and household appliances, such as silver nano carbon nanotubes for silver stain resistant textiles and cerium oxide as a fuel catalyst. These we have developed. As of up to March 2011, we have estimated about 1,300 manufacturer identified nanotech products are available in the market. So it is continuously developing, but it is still we are in the initial stage. With the development of nanotechnology, soon in the recent few days, we have moved to nanobiotechnology. Nanobiotechnology is one of the emerging fields. As a matter of fact, this is a field of crossroads of biotechnology, nanoscience, and involved many disciplines like physics, chemists, engineers, information technology, and material science, and of course biology. So this field need a lot of interdisciplinary approach. Broadly, you can say the biology and nanotechnology combines and give you nanobiotechnology. On the right hand side, you can see here we have used two words of this bio-nanotechnology, yes, and also the word nanobiotechnology. These two basically are the terminology used for different applications. If we use biological systems in nanotechnology, then it is called bio-nanotechnology. Like self-assembled nanostructures, if we have nanostructures, biopolymeric materials, biomolecular nanostructures. If we are developing nanostructures with biology, then it's called bio-nanotechnology. We are using biological materials in nanostructures. These are the examples: self-assembled nanostructures. We must know in natural phenomena, in all biology, all things are self-assembled by nature. If we are using self-assembling of biology, self-assembling of biological compounds by polymeric materials in nanotechnology, then it is bio-nanotechnology. However, sometimes we use some nanoparticles like quantum dots, quantum wires. We use these things in biological tissues, biological engineering. Then it is called nanobiotechnology. Normally, whenever we use the word nanobiotechnology, it's a combination of nanotechnology and biotechnology for development of many applications, devices, and many methods. Nanobiotechnology is ready to open new dimensions in the field of drug delivery system, dimensions in the field of development of many organs, many compatible devices for the human beings. If we have nanoscale materials, then it can allow highly sensitive detection by specific interaction with various molecules, biological molecules, on both the places, whether in the surface or inside the cell. At nano level, the detection is very high, the sensing is very high. So we need nanoscale materials for increasing the sensitivity, for increasing the detection. These two words, bio-nanotechnology and nanobiotechnology, is giving us opportunity in two ways. One, we can use many nanotechnological applications in our human body or for the welfare of human beings. On the other hand, we can also develop many things, many nanotechnological devices using biological loops and can develop many electronic devices or other devices for welfare. So it has a very wide span of development. Nanobiotechnology incorporates biotechnology at nanoscale, and this discipline helps to indicate the merger of biological research with various fields of nanotechnology. It provides many concepts that are enhanced through nanobiotechnology, and these includes nanoparticles, nanoscale phenomena that is occurring in the discipline of nanotechnology. The technical approach to biology allows scientists to imagine and create systems. Using this, by the inspiration of this, we are creating many things for us. This has a lot of potential. However, this also involves many ethical issues. And that is the reason this field has high potential to work. Whenever you want to use nano devices inside the body, many things are to be analyzed before using this. So it has a lot of things to study. The biological materials range are indicated here. Like cells are about 100 micron to 10 micron. From 10 micron, we have nucleus, mitochondrion. From 10 to 1 micron, that is called cell organelles. The virus has dimension very less than this, 100 to 550 nm. And below this, we have many things, cell materials like lipids, proteins, DNA, RNA. So whenever we are saying we are talking with nanobiotechnology, we will deal with DNA, RNA, proteins, development of these things and application of these for new synthesis process. Many fields are being searched, and out of those many fields, the most important is involvement of application of nanorobots, nanotools for medicinal purpose, for biological problems. So development of nanotools is a good work. Peptide nanosheets are being developed for medical and biological purpose. Scientists are planning to refine applications of nanotools. Imaging techniques are being developed. Now we are trying to develop many biological membranes and use of those membranes for various research purpose. Cantilever array sensors, application of nanophotonics is also a good branch. Nanophotonics is a growing branch that can replace many surgical applications and many may the change the dimension of medicinal treatments. Drug delivery system may also be changed using nanosensors. Recently, it has also been reported the use of microorganisms for synthesis of functional materials. Microorganisms can change the oxygen states of materials, and this gives a new opportunity to develop. The biosynthesis of metal nanoparticles is a new area of research. Nanomaterials can be achieved in aqueous phase under gentle and environmentally benign conditions. This approach has become an attractive force in green bio-nanotechnology for sustainable development. And that is the reason, or the one place we have developed too many things, and on another side, lot of things is to be there to develop. As an exercise of this lecture, I'm giving you two tasks. Collect some possible applications of nanobiotechnology, where it can be used, and what are the advantages for that. Another is explain how drug delivery system can be changed. When we use drug delivery, we have a convention method of drug delivery. How it can be changed? What are the possibilities with this? We have these things in coming units and we'll discuss in detail. But I would like to give you the idea so that you start some thinking in process. You have to start some thinking in this direction. In this lecture, we have discussed about emergence of nanotechnology. We discussed pre-modern era. We discussed present era. What happened in the last century, then what is the status in presently, what is developed in the form of publications and books, and then what are the development in experimental sites and industries outlook for this. Now these two lectures I think are sufficient to develop energy, that this is one of the biggest field, one of the most potential field, where lot of work is to be done. Whatever is done, it is in initial stage. So with this background, I am closing this lecture. Thank you.